Good afternoon, everyone. This video will tackle about the Monte Carlo simulation. But before that, let us have a short recap on the previous spreadsheet models. As we have seen in the previous chapters, predictive models can be estimated from data in spreadsheet using tools provided in Excel. So these predictive models can help us deal with uncertainty by giving estimates for unknown events or quantities that serve as inputs to the decision-making process. Another important extension of what-if models that help us deal with uncertainty is simulation. So we have here the Monte Carlo simulation that is essentially automates the manual what-if. So this automation allows us for very rapid and high volume what if to imitate the uncertainty and decision maker faces. By quantifying uncertainty in inputs, simulation allows us to quantify uncertainty in the outputs as we care about and therefore assess the riskiness of a decision. Excel has built-in probability functions that allow us to simulate uncertainty. So this chapter introduces the use of Monte Carlo simulation, which evaluate the impact of uncertainty on a decision. Simulation models have been successfully used in different disciplines. So we have financial applications, marketing applications, and management applications. Financial applications that includes investment planning, project selection, and option pricing. However, marketing applications includes new product development and the timing of market entry for a product. Another discipline that uses the simulation model is the management applications that include project management, inventory ordering, capacity planning, and revenue management. So, and each of these applications, uncertain quantities complicate the decision process. So as we demonstrate, a spreadsheet simulation analysis requires a model foundation of logical formulas that correctly express the relationships between parameters and decisions to generate outputs of interest. So we have a probability distribution that represents not only the range of possible values but also the relative likelihood of several various outcomes. A simulation model extends the spreadsheet modeling approach by replacing the use of single values for parameters with a possible distribution of possible values. So to evaluate a decision with a Monte Carlo simulation, an analyst identifies parameters that are not known with high degree of uncertainty and treats these parameters as random or uncertain variables. The values of random variables are randomly generated from the specified probability distributions. The simulation model uses the randomly as mentioned, randomly generated variables of random variables. Simulation results help us to make decision recommendations for the controllable inputs that address not only the average output but also the variability of the output. So in risk analysis for Sonatronics LLC, this is a company wherein we're going to identify the best case scenario, the worst case, the Sonatronic spreadsheet models, the use of probability distributions that to represent random variables, generate values for random variables with Excel, execute simulation trials with Excel, and measuring and analyzing simulation output. For the risk of sonotronics, decision makers are interested in risk analysis, that is, quantifying the likelihood and magnitude of an undesirable outcome. So when making a decision in the presence of uncertainty, the decision maker should be interested not only in the average or expected outcome, but also in information regarding the range of the possible outcomes. So we have the illustration of Sonatronics problem. Sonatronics is a startup company that manufactures medical devices for use in hospital clinics. Inspired by experiences with family members who have the battle cancer, Sonatronics founders have developed a prototype for a new device that limits healthcare workers' exposure to chemotherapy treatments while they are preparing, administering, and disposing of these hazardous medications. So the new device features an innovative design and has the potential to capture a substantial share of the market. Sonatronics would like an analysis of the first year profit. Okay, that is potential for new medical device. Because of Sonatronics' tight cash flow situation, management is particularly concerned about the potential for a loss. Sonatronics has identified the key parameters in determining first-year profit. So we have the selling price per unit, first-year administrative and advertising costs, direct labor cost per unit, parts cost per unit, and first-year demand. After conducting a market research and a financial analysis, Sonatronics estimates with a high level of uncertainty that the device's selling price will be $249 per unit, and that the first-year administrative and advertising costs will total of $1 million. So Sonatronics is not certain about the values for the cost of direct labor, the cost of parts, and the first-year demand. At this stage of the planning process, Sonatronics' base estimates of these inputs are $45 per unit for the direct cost labor, $90 per unit for the parts cost, and 15,000 units for the first-year demand. So we begin our risk analysis by considering a small set of what-if scenarios. So let us recall that Sonatronics is certain of a selling price of $249 per unit and administrative and advertising costs total of $1 million. Substituting these values into the equation that yields profit is equal to P, wherein this P is the selling price per unit. Okay, so we can have the formula of the Sonatronics first year profit by multiplying the result of selling price per unit minus direct labor cost per unit minus parts cost per unit multiplied by the first year demand minus say sub A is the advertising cost. So, to distribute, we have selling price per unit is 249, and 1 million of advertising cost total.